Hello, in this lecture we'll find out the radius of the biggest circle. In the drawing we have 4 circles. 3 circles are located inside the biggest circle. We know that the radius of this circle is equal to 4 units. The radius of this circle is equal to 9 units. The radius of the smallest circle, the radius of this circle, that is the smallest circle, is equal to 1 unit. And we want to find out the radius of this circle that those 3 circles are located in. So, first of all, I will present to you 2 new terms. When 2 circles are touching each other at one point, that is to say they are tangent to each other at one point, there are 2 types of tangency. The first type of tangency is the external lunge. When the 2 circles are touching each other externally, like in this drawing, those 2 circles are touching each other at point S externally. This is the external lunge, and here we know that the center of the small circle is at point M, and the radius of the small circle is equal to small r. The center of the big circle is at point O, and the radius of the big circle is capital R. Then the distance between their centers is actually equal to capital R plus R. So whenever you have 2 circles that are touching each other externally, like in this drawing, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it equals to capital R plus small r. So the external lunge is the first type of tangency, and we also have another type of tangency that is actually called the internal lunge. When the 2 circles are touching each other at one point internally, and then it is defined as internal lunge. Those 2 circles are touching each other at point S, and actually the distance between their centers, that is to say MO is equal to OS minus MS. OS is equal to capital R and SM equals to R, therefore OM will be equal to capital R minus small r. So whenever you have 2 circles that are touching each other internally, then the distance between their centers, that is to say OM, will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus small r. Okay, so those are the 2 types of tangency, the internal lunge and the external lunge. And now we will return to the original drawing. We will define the center of this circle, that its radius is equal to 4 units. We will define the center of this circle as point A. We will define the center of this circle as point B. And we will define the center of this circle as point C. In the drawing we have this straight line, that is actually, this straight line is tangent to those three circles at three different points. The first point of tendency between the straight line and this circle is at this point. We will define this point as point D. This is the first point of tendency between the straight line and this circle. So D is the point of tendency. And we will define the second point of tendency between the straight line and this circle, this point as point E. The straight line is tangent to this circle at this point that is defined as point E. So E is also the point of tendency of the straight line with this circle. And we will define the point of tendency of the small circle with the straight line as point F. So point F is also the point of tendency. So points F, E and D are the point of tendency of the straight line with those three circles. In the next step, we will join points A and D by straight line. AD is the radius of this circle because of the fact that line segment AD starts from the center of this circle, that is to say from point A, and ends at point D, that is the point of this circle itself, and that is exactly the definition of the radius. So AD is the radius of this circle, that is to say it equals to 4 units because the radius of this circle equals to 4 units. It is given us in the question. We will join points B and E together by a straight line. Actually, line segment BE is the radius of this circle because of the fact that it starts from the center of this circle and ends at point E, that is the point of this circle itself. Therefore, it is the radius of this circle, that is to say, it equals to 9 units. So we can write here that VE equals to 9 units. And we will join points C and F together by a straight line. CF is the radius of the smallest circle for the same reason, because it starts from the center of the circle, that is to say from point C, and ends at point E. It ends at point F, that is the point on this circle itself. Therefore, CF is the radius of this circle, that is to say it equals to 1 unit. CF equals to 1 unit. And we will define the center of the biggest circle as point O. So here, this point is the center of the biggest circle, that is to say it is point O, according to our definition. And in the next step, I will present to you a new rule that will be actually rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius, drawn to its point of tendency. I'll read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius AD of this circle that is drawn to the point of tendency, and because of the fact that this radius AD is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of this straight line with this circle, therefore the tangent FD, this tangent will be perpendicular to the radius AD, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, the radius BE is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tendency of tangent FD with this circle. Therefore, according to rule number 1, the tangent FD will be perpendicular to the radius FB. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? Likewise, we have the radius CF that is drawn to the point of tendency, that is to say it is drawn to point F, that is the point of tendency of this tangent with this circle. Therefore, according to rule number 1, the tangent DF will be perpendicular to this radius to radius FC, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, and in the next step, from point A, we will draw perpendicular to BE. So here this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from point A and BE as point P, and we will focus on quadrilateral APDE. In quadrilateral APDE, we have three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees. So 270 degrees plus the size of this angle, that is actually angle ADP. So the sum of those four angles, in total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation, and we will get that angle ADP equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle ADP is a right angle, that is to say it equals to 90 degrees. So actually in quadrilateral ADEP we have four right angles, and therefore quadrilateral ADEP is a rectangle. So we can write down that quadrilateral APDE is a rectangle and we know that the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So in rectangle APDE, side AD equals to side PE, side AD equals to side PE, but we know that side AD equals to 4 units, so we can write here that AD equals to 4 units, and from this equation PE equals to AD equals to 4, we will conclude that PE also equals to 4 units. So we can write here that PE equals to 4 units. In the next step, we will draw perpendicular from point O to DE. So here this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the intersection point between, first of all, we will define the touching point between the perpendicular from point O and DE as point M, and then we will define the intersection point between AP and OM as point S, and here in quadrilateral ASDM, this quadrilateral we have three right angles, 1, 2, 3, and the sum of three right angles is 270 degrees, plus the size of the fourth angle, that is actually angle ASM, this angle. In total, the sum of those two angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation, and we will get that angle ASM equals to 90 degrees. So angle ASM is a right angle, therefore here angle ASM, actually this angle is a right angle, therefore quadrilateral ASDM is a rectangle, quadrilateral ASDM is a rectangle, likewise quadrilateral QPEM has three right angles, 1, 2, 3. So here the sum of three right angles is 270 degrees, plus the size of this angle, that is actually angle MSP. In total, the sum of those four angles must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that angle MSP is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So actually this angle, angle MSP, is a right angle. That is to say it equals to 90 degrees. Therefore quadrilateral SPME is a rectangle. Quadrilateral SPME is a rectangle. And here we have the perpendicular OM. We have the perpendicular OM that is absolutely a straight line. And we have the rule that, so you can write down that OM is a straight line. As a perpendicular OM is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. So each angles we have at point S on this side of the straight line OM, we have here 90 degrees plus angle OSA. 90 degrees plus angle OSA. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we will subtract 90 degrees from this equation, and we will get that the size of angle OSA is equal to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle OSA is a right angle. So we can write here that angle OSA is a right angle. So actually here we found that all the three quadrilaterals here, quadrilateral ADPE is a rectangle, quadrilateral ASMD is a rectangle, and quadrilateral SPME is also a rectangle. So if you focus on quadrilateral, on rectangle ADSM, on rectangle ADSM, AD equals to SM, according to the rule that the opposite sides of a rectangle are equal to each other. AD equals to SM. But AD equals to 4 units. It is the radius of this circle. AD equals to 4 units. So from this equation, SM equals to AD equals to 4, we will conclude that SM also equals to 4 units. Okay, here we can write down that SM also equals to 4 units. So what is the value of the length of line segment BP? You can see it easily from the drawing that the length of line segment BP is equal to BE minus PE. BP equals to BE minus PE. Okay? I'll repeat again. The length of line segment BP will be equal to BE minus PE. So BP equals to BE. We know that BE equals to 9 units. It is the radius of this circle. PE equals to 9 minus PE. We already found out that PE equals to 4 units. So in conclusion, BP equals to 9 minus 4, that is 5. So we found out that BP equals to 5 units. So we can write here that BP equals to 5 units. In the next step, we will join points A and B together by a straight line. So what is the length of line segment AB? A is the center of this circle, that its radius is 4 units. B is the center of this circle, that its radius is equal to 9 units. Those two circles have an external lunge between them, that is to say, they are touching each other externally at this point. This is the point of tendency, and therefore whenever you have two circles with an external lunge between them, then the distance between their centers, that is to say AB, will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this circle, that is 4 units, plus the radius of this circle, that is 9 units, and 4 plus 9 is 13. So we found out that AB equals to 13 units. We can write here that AB equals to 13 units. So in the next step, we will focus on the right triangle, triangle ABP. We know that AB equals to 13 units, BP equals to 5 units. So we will implement the Pythagoras theorem on the right triangle, triangle ABP. So according to the Pythagoras theorem, on the right triangle, triangle ABP, here the letter PT is abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, on the right triangle ABP, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AB, so the square of the hypotenuse is AB squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BP squared plus AP squared. So I'll repeat again, in the right triangle ABP, according to the Pythagoras theorem, AB squared equals to BP squared plus AP squared. So here AB equals to 13 units, therefore AB squared is 13 squared. 13 squared is 169. And it equals to BP squared. BP equals to 5, so BP squared is 5 squared. 5 squared is 25 plus AP squared. So in conclusion, we found out that 169 equals to 25 plus AP squared. We will subtract 25 from this equation and we'll get that 169 minus 25 is 144. So we found out that AP square equals to 144. Here we'll take a root out of this equation and we'll get that AP equals to the square root of 134. The square root of 134 is 12. So we found out that AP equals to 12 units. We can write here that AP equals to 12 units. And because of the fact that quadrilateral ADEP is a rectangle, so in rectangle ADEP, the opposite sides are equal to each other. That is to say, AP equals to DE. Here, AP equals to DE. But we just right now found out that AP equals to 12 units. Here, AP equals to 12 units. So we can write here that AP equals to 12 units. So from this equation, 12 equals to AP equals to DE, we will conclude that DE also equals to 12 units. DE equals to 12 units. So we can write here that DE equals to 12 units. In the next step, we will define ME as X. Again, ME equals to X according to our definition. And because of the fact that SPME is a rectangle, in rectangle SPME, this rectangle, the opposite sides are equal to each other. that is to say ME equals to SP. ME equals to SP in rectangle SPME. In rectangle SPME, ME equals to SP, but according to our definition, ME equals to X. According to our definition, ME equals to X. So from this equation, we will conclude that SP also equals to X. SP also equals to X. Likewise, AQDM is a rectangle. But before that, what is the value of dm? The value of dm, the length of dm, you can see it easily from the drawing that dm equals to de minus me. Again, dm equals to de minus me. de minus me. Okay, de equals to dm equals to de minus me. So dm equals to de, that is 12 units, minus dm, that is x, according, minus me, that is x, according to our definition. So in conclusion, we found out that dm equals to 12 minus x. dm equals to 12 minus x. So here in rectangle ASDM, in rectangle ASDM, the opposite sides are equal to each other. That is to say, dm equals to as. dm equals to as. Again, in rectangle ASDM, you know that dm equals to as, but dm equals to 12 minus x. dm equals to 12 minus x. From this equation, 12 minus x equals to dm equals to as. We will conclude that as also equals to 12 minus x. as also equals to 12 minus x. What is the value of OS? The value of line segment OS you can see it easily from the drawing that OS equals to OM minus SM. Again, OS equals to OM minus SM. We will define we will define OM as Y. OM equals to Y according to our definition. So we can write here that OM equals to Y according to our definition. So in conclusion, OS equals to OM, that is Y, minus SM. SM, we already found out that SM equals to 4 units. So in conclusion, we found out that OS equals to Y minus 4. You can write here that OS equals to Y minus 4. Okay? And what is the value of AO? The value of line segment AO A is the center of this circle that its radius is equal to 4 units. O is the center of the biggest circle that its radius is equal to capital R according to our definition. The radius of the biggest circle equals to capital R. I'll write it down. Capital R is the radius that we are looking for, is the radius of the biggest circle. So I'll repeat again, A is the center of this circle that its radius equals to 4 units. O is the center of the biggest circle that its radius equals to capital R. And so those two circles, the biggest circle and this circle, have an internal notch between them at this point. That is to say, they are touching each other at this point. And therefore, whenever you have an internal notch between two circles, then the distance between their centers, that is to say A or O, will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus 4. So AO equals to capital R minus 4. So in the next step, I will copy the right triangle AOS in a new page, and we will implement the Pythagoras theorem on this green right triangle AOS. So I'll copy the right triangle AOS. AO equals to R minus 4. We have already found out that AS equals to 12 minus X, and we also found out that OS equals to Y minus 4. AD equals to 4 units. SM also equals to 4 units. OM equals to Y. So in the green right triangle AOS, we will implement the Pythagoras theorem on the triangle AOS. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse is AO, so the square of the hypotenuse is AO squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OS squared plus AS squared. So here AO equals to R minus 4, so AO squared will be equal to R minus 4 squared. That equals to OS squared. OS equals to Y minus 4, so OS squared will be equal to Y minus 4 squared plus AS squared. AS equals to 12 minus X, so AS squared will be equal to 12 minus X squared. Here we'll open the brackets on both sides of equation number 1, and we will get that according to equation number 1, R squared plus 16 minus 8R equals to Y minus 4 squared is Y squared plus 16 minus 8Y plus 12 minus X squared 12 minus x squared equals to 144 plus x squared minus 24x here we have 16 on both sides of equation number 1, so 16 will get cancelled. So we will add 8r to this equation, equation number 1, and we will get that r squared equals to 8r minus 8y plus 144 minus 24x plus x squared plus y squared. Here we'll subtract x squared and y squared from this equation, equation number 1, and we'll get that according to equation number 1, r squared minus x squared minus y squared equals to, here we have 8r minus 8y, so we'll take 8 as a common factor, we take out s as a common factor, so inside the brackets we will have r minus y plus 144 minus 24x. So in conclusion, we found out that according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. So in the next step, we will draw perpendicular from point O to BP, and we will define the touching point between the perpendicular from point O to BE as point T. So I will copy the right triangle OBT and we will implement the Pythagoras theorem on the right triangle OBT. So this is the right triangle, triangle OBT. We'll focus on quadrilateral OTME. Quadrilateral OTME has three right angles, 1, 2, 3. The sum of three right angles is 270 degrees, plus the size of the fourth angle, that is actually angle MOT. In total, the sum of those four angles must be equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we'll get that angle MOT is equal to 90 degrees. So this angle is a right angle, it equals to 90 degrees. So actually, therefore, quadrilateral OTME is a rectangle quadrilateral OTME is a rectangle and because of the fact that the opposite sides of a rectangle are equal to each other, that is to say ME equals to OT, ME equals to OT, but ME equals to X according to our definition. So we can write here that ME equals to X. From this equation, OT equals to ME equals to X, we will conclude that OT is also equals to X. So here OT equals to X, and we know that BE is the radius of this circle that equals to 9 units. OM is equal to Y according to our definition. Here you can see OM equals to Y according to our definition. And because of the fact that the opposite sides in a rectangle OTME are equal to each other, we will get that OM equals to TE, OM equals to TE, but OM equals to Y according to our definition. So from this equation, Y equals to OM equals to TE, we will conclude that TE also equals to Y. TE also equals to Y. So what is the value of BT? You can see it easily from the drawing that BT equals to BE minus TE. Again, BE minus TE equals to BT. Again, BE minus TE equals to BT. So BT will be equal to BE, that is 9 units, minus TE, that is Y. So in conclusion, we found out that BT equals to 9 minus Y. BT equals to 9 minus Y. And what is the value of OB? The value of OB O is the center of the biggest circle that its radius is equal to capital R. B is the center of this circle that its radius is equal to 9 units. The biggest circle and this circle have an internal notch between them at this point, that is to say they are touching each other at this point, and therefore the distance between their centers, that is to say OB, will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus 9. Capital R minus 9. So we can write here that OB equals to capital R minus 9. Now we can implement the Pythagoras theorem on the green right triangle OBT. So according to the Pythagoras theorem, in the green right triangle OBT, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OB, so the square of the hypotenuse is OB squared. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to BT squared plus OT squared. So, according to the Pythagoras theorem, in the right triangle OBT, OB squared equals to BT squared plus OT squared. We have already found out that OB equals to R minus 9, so OB squared will be equal to R minus 9 squared. And it equals to BT squared. BT equals to 9 minus y, so BT squared will be equal to 9 minus y squared plus OT squared. OT equals to x, so OT squared will be equal to x squared. So, in conclusion, we found out that according to equation number 2, R minus 9 squared equals to 9 minus y squared plus x squared. Here we will open the brackets on both sides of equation number 2, and we will get that R minus 9 squared is equal to R squared plus 81 minus 18 R, that equals to 9 minus y squared. 9 minus y squared is 81 plus y squared minus 18y plus x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. And we will add 18 out to this equation number 2. And we will get that according to equation number 2, R squared equals to 18R minus 18y plus x squared plus y squared. If we subtract x squared and y squared from this equation number 2, and we will get that according to equation number 2, r squared minus x squared minus y squared equals to, here we have 18r minus 18y, so we'll take 18 out of those two expressions as a common factor. Inside the brackets we will have r minus y. So in conclusion, we found out that r squared minus x squared minus y squared equals to 18 times r minus y. So if in the next step we will draw perpendicular from point C to BE, so this angle equals to 90 degrees and this angle will be also equal to 90 degrees. We will define the touching point of the perpendicular from point C to BE as Q. So in quadrilateral QCEF, we have 1, 2, 3 right angles. And the sum of 3 right angles is 270 degrees, plus the fourth angle, the size of the fourth angle, this is actually this angle, angle QCF. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We'll subtract 270 degrees from this equation, and we'll get that the value of angle QCF equals to 360 degrees minus 270 degrees, it equals to 90 degrees. So angle QCF is a right angle. Therefore, quadrilateral QCEF has 4 right angles. From the fact that quadrilateral QCEF has 4 right angles, we conclude that quadrilateral QCEF is a rectangle. Quadrilateral QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other, that is to say CF equals to QE. CF is equal to QE, but CF equals to 1 unit because it is the radius of the smallest circle. CF equals to 1 unit. So from this equation 1 equals to CF equals to QE, we will conclude that QE is also equal to 1 unit. So we can write here that QE is equal to 1 unit, QE equals to 1 unit, in the next step we will join points B and C together by a straight line. What is the value of BC? B is the center of this circle that its radius is equal to 9 units. C is the center of the smallest circle that its radius is equal to 1 unit. And those two circles have an external notch between them. That is to say, they are touching each other externally, and therefore the distance between their centers, that is to say the distance BC, will be equal to the sum of the lengths of their radii. And the sum of the lengths of their radii is equal to 9 plus 1. 9 plus 1 is 10, so we found out that BC is equal to 10 units. In the next step, I will copy the right triangle QCF in a new page, and we will implement the Pythagoras theorem on this right triangle QCB. So this is the right triangle QPC. We found out that BC equals to 10 units. What is the value of BQ? You can see it easily from the drawing that BQ equals to BE minus QE. Again, BQ equals to BE minus QE. So I will write it down. BQ equals to BE minus QE. But we have already found out that BE equals to, BE is actually the radius of this circle. The radius of this circle is equal to 9 units. So BE equals to 9 units. And QE equals to 1. So in conclusion, we found out that BQ is equal to 8 units. So we can write here that BQ equals to 8 units. Now we will implement the Pythagoras theorem on this right triangle, triangle QBC. According to the Pythagoras theorem, in the right triangle, triangle QBC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BC squared equals to BQ squared plus QC squared BC equals to 10, so BC squared is 10 squared, 10 squared is 100. BQ equals to 8 units, so BQ squared is 8 squared, 8 squared is 64, plus QC squared. Here we'll subtract 64 from this equation, and we will get that QC squared equals to 100 minus 64 is 36. So here we'll take a root out of this equation and we get that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units. And we have already found out that QCEF is a rectangle. You can see here QCEF is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, QC equals to EF. QC equals to EF, but we just right now found out that QC equals to 6 units, so we can write here that QC equals to 6. From this equation, QC EF equals to QC equals to 6. We will conclude that EF is also equals to 6. EF equals to 6. And right here that EF equals to 6. And also here, EF equals to 6. In the next step, we will draw perpendicular from point C to OM. So this angle equals to 90 degrees, and this angle will also equal to 90 degrees. We will define the touching point of the perpendicular from point C to OM as U, and UMCF is a rectangle, or UCMF is a rectangle. UCMF is a rectangle, And we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to UM, CF equals to UM. CF equals to UM, but we know that CF equals to 1 unit. It is the radius of the smallest circle. From this equation, UM equals to CF equals to 1. We will derive, we conclude that UM is also equals to 1 unit. So we can write here that UM is equal to 1 unit. And likewise, because of the fact that UCMF is a rectangle, therefore MUC will be equal to MF, UC will be equal to MF, but MF equals to x plus 6. We already found out that MF equals to x plus 6. From this equation, UC equals to MF equals to x plus 6. We will conclude that UC is also equals to x plus 6. UC is also equals to x plus 6. In the next step, we will join point C and O together by a straight line. And we will implement the Pythagoras theorem on the right triangle OUC. So I will copy the right triangle OUC in a new page, and we will implement the Pythagoras theorem on this right triangle, right green triangle. So we have the right triangle OUC. Here we have the right green triangle, triangle OUC. First of all, we'll find out the value of side UO. For OU, you can see it is very easy to see that OU equals to OM minus UM. Again, OU is equal to OM minus UM. OM minus UM equals to OU. So OU is equal to OM. OM is equal to Y according to our definition. UM equals to 1. So in conclusion, we found out that OU equals to Y minus 1. Y minus 1. And we've already found out that UC equals to X plus 6. What is the value of OC? Here OC, O is the center of the biggest circle that is radius is equal to capital R. C is the center of this circle, the smallest circle that is radius is equal to 1 unit, and OC is the distance between their centers and the distance between two circles that have an internal length between them. That is to say, they are touching each other internally. The biggest circle and the smallest circle are touching each other at this point. This is the point of contact, the point of tendency between those two circles. Whenever you have two circles that are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii, and the difference between the length of the radii of the biggest circle and the small circle, it is actually equals to R minus 1. So OC equals to R minus 1, capital R minus 1. So we can write here also that OC equals to capital R minus 1. So now we can implement the Pythagoras theorem on this right triangle, triangle OUC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OC, so the square of the hypotenuse is OC squared. And it equals to the sum of the squares of the perpendiculars, that is to say, it equals to UC squared plus OU squared. Again, in the right triangle, triangle OUC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OC, the square of the hypotenuse is OC squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to UC squared plus OU squared. Okay? So actually, OC equals to R minus 1, so OC squared is R minus 1 squared. And it equals to OC squared. OC is x plus 6, so OC squared will be equal to x plus 6 squared plus OU squared. OU equals to y minus 1, so OU squared will be equal to y minus 1 squared. So in conclusion, we found out that according to equation number 3, r minus 1 squared equals to x plus 6 squared plus y minus 1 squared. Here we'll open the brackets on both sides of equation number 3 and we will get that r minus 1 squared according to equation number 3 equals to r squared plus 1 minus 2r, and it equals to x plus 6 squared, x plus 6 squared equals to x squared plus 36 plus 12x plus y minus 1 squared, y minus 1 squared equals to y squared plus 1 minus 2y. So here we have 1 on both sides of equation number 3, so 1 will get cancelled. We will add 2r to this equation, equation number 3, and we will get that r squared equals to 2r minus 2y plus 36 plus 12x plus x squared plus y squared. Here we'll subtract x squared and y squared from this equation, equation number 3, and we will get that x squared r squared minus x squared minus y squared equals to here 2r minus 2y. We will take a common factor 2 as we will take out 2 as a common factor, and inside the brackets we will have r minus y plus 36 plus 12x. So in conclusion, we found out that according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. And according to equation number 2, we've already found out that r squared minus x squared minus y squared equals to 18 times r minus y. And according to equation number 1, we've already found out that r squared minus x squared minus y squared equals to 8 times r minus y plus 144 plus minus 24x. So here we create equation number 4 that states that rx minus x squared minus y squared according to equation number 1 must be equal to rx minus r squared minus x squared minus y squared according to equation number 2. So we write it down that according to equation number 4, r squared minus x squared minus y squared according to equation number 1, that equals to 8 times r minus y plus 144 minus 24x. It must be equal to r squared minus x squared minus y squared according to equation number 2, that is actually equals to 18 times r minus y. Here we subtract 8 times r minus y from this equation, and we will get that according to equation number 4, 144 minus 24x equals to 10 times r minus y so here we divide by 10 equation number 4, and we get that according to equation number 4, r minus y equals to 144 minus 24x over 10. Here we divide both the numerator and the denominator of equation number 4, of this side of equation number 4 by 2, and we will get that r minus y equals to 144 over 2 is 72, minus 24x over 2 is 12x, and 10 over 2 is 5. So in conclusion, we found out that r minus y according to equation number 4 equals to 72 minus 12x over 5. In the next step, we will create equation number 5 that states that r squared minus x squared minus y squared according to equation number 2 must be equal to r squared minus x squared minus y squared according to equation number 3. So actually, question number 5 states that r squared minus x squared minus y squared according to equation number 4, this is actually equals to 18 times r minus y must be equal to r squared minus x squared minus y squared according to equation number 3, that is equal to 2 times r minus y plus 36 plus 46 plus 12x. Here we subtract 2 times r minus y from this equation number 5, and we'll get that 16 times r minus y 16 times r minus y 16 times r minus y, that equals to 36 plus 12x. Here we divide equation number 5 by 16, and we get that r minus y according to equation number 5 equals to 36 plus 12x over 16. Here we divide both the numerator and the denominator on this side of equation number 5 by 4, and we will get that according to equation number 5, r minus y equals to 36 over 4 is 9, plus 12x over 4 is 3x, and 16 over 4 is 4. So in conclusion, we found out that r minus y according to equation number 4 according to equation number 5 equals to 9 plus 3x over 4, while r minus y according to equation number 4 is equal to 72 minus 12x over 5. In the next step, we'll create equation number 6 that states that r minus y according to equation number 5, r minus y according to equation number 4 must be equal to r minus y according to equation number 5. So equation number 6 states that r minus y according to equation number 4 that is actually equals to 72 minus 12x over 5 must be equal to r minus y according to equation number 5 that is actually equals to 9 plus 3x over 4. Here we'll cross multiply equation number 6 and we'll get that according to equation number 6 72 minus 12x minus 12x times 4 equals to 5 times 9 plus 3x. Here we'll open the brackets on both sides of equation number 6. And we'll get that 4 times 72 is 288, minus 4 times 12x is minus 48x, and it equals to 5 times 9 is 55, plus 5 times 3x is 15x. So here we subtract 45 from this equation, equation number 6, and we get that according to equation number 6, 288 minus 45 is 243. That equals to 15x plus 48x is 63x. Here we will divide equation number 6 by 63, and we get that x equals to 243 over 63. Two hundred 43 over 63. So here we divide both the numerator and the denominator on this side of equation number 6 by 9, and we will get that x equals to 243 over 6 is 36, and 63 over 9 is 7. This is actually 243 over 9 is 27. So x equals to 27 over 7. We found out that x equals to 27 over 7. In the next step, we will put the value of x inside equation number 5. So according to equation number 5, r minus y is equal to 36 plus 12x over 16, and we have already found out that x equals to 27 over 7. So r minus y according to equation number 5 is equal to 36. So here, actually r minus y is equal to 9 plus 3x over 4, because we divided both the numerator and the denominator of this expression by 4. So here we'll get that r minus y equals to 9 plus 3 times 27 over 7 over 4. So according to equation number 5, we found out that r minus y is equal to 9 plus 3 times 27 is 81 over 7 over 4. Here we will multiply 9 by 7 and then we will divide it by 7 in order to have a common factor with 81 over 7. And we get that according to equation number 5, r minus y is equal to 9 times 7 is 63 plus 81 over 7 over 4. So according to equation number 5, r minus y is equal to 63 plus 81 is 144, and 7 times 4 is 28. Here we will divide both the numerator and the denominator on this side of equation number 5 by 4, and we will get that r minus y according to equation number 5 is equal to 144 over 4 is 36, and 28 over 4 is 7. So in conclusion, we found out that r minus y according to equation number 5 is equal to 36 over 7, and we have already found out that x equals to 27 over 7. Now we'll go to equation number 2, and we will substitute r minus y and x by the values that we found for them. So according to equation number 2, we have only found out that r squared minus x squared minus y squared is equal to 18 times r minus y and we know that r squared minus y squared is equal to r plus 1 r minus 1 according to the algebraic identity that a squared minus b squared equals to a plus b times a minus b. So r squared minus y squared is equal to r plus y times r minus y minus x squared, that equals to 18 times r minus y so here we subtract r minus y by 36 over 7 and x by 27 over 7, and we will get that r plus y times r minus y is 36 over 7, and minus x squared, x is 27 over 7, so it will be minus 27 over 7 squared, that equals to 18 times r minus y, and r minus y is 36 over 7. So it is 18 times r minus y is 18 times 36 over 7. Here we multiply this equation number 2 by 7, and we get that r plus y times 36 equals to 27 times 27 over 7 minus 18 times 36. Here we divide this equation by 9, and we'll get that 36 over 9 is 4, so 4 times r plus y equals to 27 over 9 is 3, so it is 3 times 27 over 7, and 18 over 9 is 2, so and 2 times 36 is 72. So here we will multiply 72 by 7, and then we divide it by 7 in order to have a common factor with this expression, and we get that according to equation number 2, four times r plus y is equal to 3 times 27 is 81 over 7 times 72 all divided by 7, so here 7 times 72 is 504, so 4 times r plus y equals to 81 plus 504 over 7. Here we will divide this equation by 4, and we'll get that r plus y is equal to 81 plus 504 is 585 over 7 times 4 is 28. So we found out that according to equation number 2, r plus y equals to 585 over 28, and according to equation number 5, we've already found out that r minus y is equal to 36 over 7. Here we'll multiply this side of equation number 5 by 4. 4 of the numerator and the denominator will multiply by 4. And we get that according to equation number 5, r minus y is equal to 36 times 4 is 144 and 7 times 4 is 28. And according to equation number 2, we've already found out that r plus y is equal to 585 over 28. We subtract, we'll add equation number 2 to equation number 5, and we'll get that r plus r is 2r, y plus minus y is y minus y, that is 0, that equals to 585 over 28 plus 144 plus 585 is equal to 729, all divided by 28. Here we divide this equation by 2 and we get that the radius that we are looking for, that is to say capital R, the radius of the biggest circle, equals to either 729 over 56 units, or in terms, we can represent it as also as 13.018 units. So I repeat again, the radius of the biggest circle is equal to either 729 over 56 units, or we can present it also as 13.018 units. Okay, this is the answer to the question. In the next step, I will summarize the lecture. Actually, we wanted to find out the radius of this big circle. Inside this big circle we have 3 other small circles. The radius of this circle is 4 units, the radius of this circle is 9 units, and the radius of this circle is 1 unit, and we want to find out the radius of the biggest circle. So in the first step I presented to you a new rule, actually two new terms. The first term is the external lunge. Whenever you have 2 circles that are touching each other, they can touch each other in 2 different ways. The first way of touching each other is by the external lunge, but they can touch each other externally, like in this drawing. The point of contact or the point of tendency is at point S, and here the distance between their centers, that is to say MO, is equal to capital R plus small r. So whenever 2 circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it is actually equals to R, capital R plus small r. This is the first way of 2 circles that they can touch each other, and the second way that two circles can touch each other is that they can touch each other internally. That is to say, here we have those two circles are touching each other internally at point S. This is actually the internal lunge, and the point of contact or the point of tendency is here at point S. They touch each other at point S, and the distance between their centers, that is to say OM, equals to capital R minus small r. You can see it easily that OM equals to SO minus MS, that is to say it equals to OS, that is capital R, minus MS, that is small r. So here OM equals to capital R minus small r. So whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between their radii, or the difference between the lengths of their radii. In this case, this equals to capital R minus small r. And the second way that the two circles can touch each other, then they can touch each other. So this is the internal lunge, and the external lunge is that when the two circles are touching each other externally at this point S, and the distance between their centers is equal to the sum of the lengths of their radii. In this case is capital R plus small r. Then we define the center of this circle as point A, the center of this circle as point B, and the center of this circle as point C. And we have here this straight line is tangent to the three circles at 3 points. The first point of tendency is here. This straight line is tangent to this circle as point D. This straight line is tangent to this circle as point E, and this straight line is tangent to the smallest circle at point F. Then we join together points A and D by straight line, points A and O and M by straight line, and B and E by straight line, and C and F by straight line. Line segment AD is the radius of this circle because of the fact that it starts from the center of the circle and ends at point D, that is the point of the circle itself. Therefore AD is the radius of this circle. Likewise here, BE is the radius of this circle that equals to 9 units. Why? Because it starts from the center of the circle and ends at point E, that is the point of this circle itself. Therefore BE is the radius of this circle, that is to say it equals to 9 units. Likewise CF is the radius of this circle that equals to 1 unit. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have this radius, the radius AD of this circle is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of this tangent with this circle. Therefore, according to rule number 1, the tangent FD will be perpendicular to the radius AD, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we have here the radius BE is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tendency of this tangent with the circle. Therefore, according to rule number 1, this tangent, the tangent FB will be perpendicular to the radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, here this tangent, the radius CF is drawn to the point of tangency, that is to say it is drawn to point F, that is the point of tangency of this tangent with this circle. Therefore, the tangent will be perpendicular to the radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so in the next step, we join points A and from point A we draw perpendicular to BE. So this angle equals 90 degrees and this angle equals to 90 degrees. And we define the touching point between the perpendicular from point A and BE as point P. So here in quadrilateral APDE we have 3 right angles, 1, 2, 3. And the sum of 3 right angles is equal to 270 degrees. 270 degrees plus the size of the fourth angle, that is actually angle ADP. Here in the right triangle ADPE, we have 3 right angles. So the sum of 3 right angles is 270 degrees. The sum of 3 angles plus this angle, this is actually angle DAP. In total, the sum of those 4 angles, they must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that angle ADP is equal to 90 degrees. This angle is equal to 90 degrees. Therefore, quadrilateral ADPE is 4 right angles, and for that reason, quadrilateral APDE is a rectangle. Quadrilateral APDE is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PE. AD equals to PE, but AD equals to 4 units. It is given us in the question that AD is the radius of this circle that equals to 4 units. From this equation, 4 equals to AP, 4 equals to AD equals to PE, we will conclude that PE also equals to 4 units. Then we focused from point O, we draw perpendicular to DE. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We define the touching point from point O, and we defined the touching point from point O and DE as point M. So the touching point of the perpendicular from point O and DE is defined as point M. And then we focus on the triangle ASDM, this quadrilateral. In this quadrilateral, we have 3 right angles, 1, 2, 3, 1, 2, 3, and the sum of 3 right angles is equal to 270 degrees. So 270 degrees plus this angle, that is angle ASM. In total, the sum of those four angles must be equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we got that this angle ASM equals to 90 degrees. Therefore, triangle ASDM, a quadrilateral ASDM that has four right angles, is a rectangle. Okay? And here we focused on quadrilateral SPME, this quadrilateral has three right angles, 1, 2, 3, and the sum of three right angles is 270 degrees, so 270 degrees plus the size of this angle, that is actually angle MSP, that is actually angle MSP. This angle is angle MSP. So in total, the sum of those four angles must be equal to 360 degrees. We subtracted 270 degrees from this equation and found out that angle MSP is a right angle, so this angle is equal to 90 degrees. So therefore, quadrilateral MSPE has four right angles, therefore quadrilateral MSPE is a rectangle. Okay, this quadrilateral is a rectangle. This quadrilateral ASDM is also a rectangle, and quadrilateral ADPE is also a rectangle. So all three quadrilaterals, all the three quadrilaterals are rectangles. We proved it. So here, from point O, we drew perpendicular to DE, so OM is perpendicular. OM is perpendicular, it is absolutely a straight line. So we can write down that OM is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. So which angles we have at point S? We have here 90 degrees plus the size of angle OSA. In total, the sum of those two angles must be equal to 180 degrees. Here 90 degrees plus angle OSA. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that angle OSA equals to 90 degrees. So this angle is equal to 90 degrees. Therefore, the green triangle AOS is a right triangle because it has one angle that equals to 90 degrees. Angle OSA is a right angle. Therefore, triangle OSA is a right triangle. So, in rectangle ADSM, this rectangle, we know that AD equals to SM according to the rule that the opposite sides of a rectangle are equal to each other. Therefore, AD equals to SM. AD equals to SM, but AD equals to 4 units. It is the radius of this circle. So from this equation, 4 equals to AD equals to SM, we conclude that SM also equals to 4 units. Then we found out the value of this line segment VP. What is the value of line segment VP? BP equals to BE minus PE. Again, BE minus PE equals to BP. BP equals to BE minus PE, but B equals to 9 units. It is the radius of the circle. PE, we found out that PE equals to 4 units, so in conclusion we found out that the length of line segment BP equals to 9 minus 4, that is 5. So BP equals to 5 units. Then AB, we found out the value of AB. We join together points A and B by a straight line. We just right now found out that BP equals to 5 units. And here what is the length of line segment AB? The length of line segment AB, it is actually, we know that A is the center of this circle, that its radius is equal to 4 units. B is the center of this circle, that its radius equals to 9 units. Those two circles have an external notch between them at this point. They touch each other externally at this point. Therefore, whenever you have two circles that touch each other externally, then the distance between their centers, that is to say AB, will be equal to the sum of the lengths of their radii. And the radius of this circle is equal to 9 units, the radius of this circle is equal to 4 units. 9 plus 4 is 13, that is to say the length AB equals to 13 units. So we know that AB equals to 13 units, BP equals to 5 units. So we focused on the right triangle, triangle ABP. We implemented the Pythagoras theorem on the right triangle, triangle ABP. Okay, in the right triangle, triangle ABP. Here, in the right triangle, triangle ABP, is actually this page. In the right triangle ABP, according to the PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB. Therefore, the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to BP squared plus AP squared. AB equals to 13 units. So AB squared will be equal to 13 squared. 13 squared is 169 plus, so 169 equals to BP squared. BP equals to 5. So BP squared is 5 squared. 5 squared is 25. So in conclusion, we found out that 169 equals to 25 plus AP squared. We subtracted 25 from this equation and we found out that 169 minus 25 is 144. So we found out that 144 equals to AP squared. We took a root out of this equation and we found out that AP equals to the square root of 144. The square root of 144 is 12. So we found out that AP equals to 12 units. And we already found out that ADEP is a rectangle, is quadrilateral is a rectangle, ADEP is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AP equals to DE, AP equals to DE. But we just right now found out that AP equals to 12 units. So from this equation, DE equals to AP equals to 12, we will conclude that DE also equals to 12 units. So we can write here that DE equals to 12 units. Then we define ME as X according to our definition. ME equals to X. And what is the value of, actually we know that rectangle SPME, in rectangle SPME, here rectangle SPME, the opposite sides are equal to each other. That is to say, SP equals to ME, SP equals to ME, but ME equals to X according to our definition. So from this equation, X equals to ME equals to SP, we will conclude that SP also equals to X. Here, SP also equals to X. And what is the value of dm? Dm equals to dE minus ME. Dm equals to dE minus ME. So dm equals to dE, that is 12 units, minus ME, that is X according to our definition. So in conclusion, we found out that dm equals to 12 minus X. Dm equals to 12 minus X. And then so here we focused on the right triangle OAS. In the right triangle OAS, what is the value of AO? A is the center of this circle that is radius is equal to 4 units. O is the center of the biggest circle that is radius equal to capital R according to our definition. This circle and this biggest circle have an internal notch between them at this point. That is to say, they are touching each other at this point, and any two circles that have an internal notch between them, the distance between their radii will be equal the distance between their centers, that is to say OA will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus 4. So we found out that the hypotenuse AO equals to capital R minus 4. Here, according to our definition, OM equals to Y, and we have already found out that SM equals to 4 units, so OS will be equal to OM minus SM. OS equals to OM minus SM. That is to say, and we know that OM equals to Y. That is to say, OS equals to OM, that is Y, minus SM, that is 4. In conclusion, we found out that OS equals to Y minus 4. OS equals to Y minus 4. And here, AS, we know that MD equals to 12 minus X. We've already found out that MD or DM equals to 12 minus X. And we know that we have already proved that quadrangle ASDM is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say, AS equals to DM. AS equals to DM, but we have already found out that DM equals to 12 minus X. So from this equation, AS equals to DM equals to 12 minus X, we will conclude that AS also equals to 12 minus X. So here we implemented the Pythagoras theorem on this right great triangle AOS. According to the Pythagoras theorem, the square of the hypotenuse, that is AO square, equals to the sum of the squares of the perpendiculars, that is to say, it equals to OS square plus AS square. So here, AO equals to R minus 4, so AO square will be equal to R minus 4 square, and it equals to OS square. OS equals to Y minus 4, so OS square will be equal to Y minus 4 square plus AS square. AS equals to 12 minus X, so AS square will be equal to 12 minus X square. Here we open brackets on both sides of equation number 1, And we found out that r minus 4 squared equals to r squared plus 16 minus 8r, and it equals to y minus 4 squared. Y minus 4 squared equals to y squared plus 16 minus 8y plus 12 minus x squared. 12 minus x squared equals to 144 plus x squared minus 24x. Here we have 16 on both sides of equation number 1, so 16 will get cancelled. And then we added add r to this equation number 4, and we know that r squared equals to 8r minus 8y minus 144 minus 24x plus x squared plus y squared. Here we subtracted 8r, x squared and y squared from this equation number 1, and we took a common factor of 8 out of those two expressions, and in conclusion we found out that according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. Okay, and then here from point O we draw perpendicular to BE, so this angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the touching point of the perpendicular from point O to BE is point T. Then we focused on the right triangle OBT, and we implemented the Pythagoras theorem on this right triangle OBT. So I copied that right triangle OBT in a new page, and we implemented the Pythagoras theorem on this right triangle. This is triangle OBT. So here, what is the value of OB? Here we have OB. O is the radius of the biggest circle. O is the center of the biggest circle that is radius equal to capital R. B is the center of this circle that is radius is equal to 9 units. So OB is the distance between the centers of the biggest circle and this circle. And the biggest circle and this circle have an internal notch between them at this point. That is to say, they are touching each other internally at this point, and any two circles that are touching each other internally, then the distance between their circles will be equal to the difference between the lengths of their radiuses. That is to say, it will be equal to capital R minus 9. So we found out that OB equals to capital R minus 9. Here, what is the value of BT? You can see it easily from the drawing that BT equals to BE minus TE. And here, in quadrilateral, we know that OT, ME, in quadrilateral OTME, we have 3 right angles, 1, 2, 3, so 270 degrees, plus angle, this angle MOT. In total they must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that angle MOT, this angle equals to 90 degrees. Okay, so here all the angles of quadrilateral OTME are equal to 90 degrees, therefore quadrilateral OTME is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, OM equals to TE. OM equals to TE, but OM equals to TE, but OM equals to Y according to our definition. Therefore, from this equation we will conclude that TE also equals to Y. So here BT equals to BE minus TE. So BT equals to BE minus TE, that is to say BT equals to BE, that is 9 units, minus TE, that is Y. So in conclusion we found out that BT equals to 9 minus Y. Likewise, because of the fact that quadrilateral OTME is a rectangle and the opposite sides of a rectangle are equal to each other, we will conclude that ME equals to OT, ME equals to OT, but ME equals to X according to our definition. So from this equation X equals to ME equals to OT, we will conclude that OT also equals to X. OT also equals to X. Now we can implement the Pythagoras theorem on this right green triangle, triangle OBT. According to the Pythagoras theorem, the square of the hypotenuse, that is to say OB square, must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to BT square plus OT square. Okay, and OB square equals to BT square plus OT square. OB equals to R minus 9. So OB square is R minus 9 square. BT equals to 9 minus Y. So BT square will be equal to 9 minus Y square plus OT square. OT equals to X. So OT square is X square. So in conclusion, we found out that according to equation number 2, R minus 9 square equals to 9 minus Y square plus X square. Here we open the brackets on both sides of equation number 2, and we got that R minus 9 square equals to R square plus 81 minus 18R, that equals to 9 minus Y square. What is 9 minus Y square? 9 minus Y square is 9 squared, that is 81, plus Y square minus 18Y plus X squared. We added 18R to this equation, equation number 2, and we got that R squared equals to 18R minus 18Y plus X squared plus Y squared. Here we took 18 as a common factor out of those two expressions, and we got that 18R minus 18Y equals to 18 times R minus Y. So, and we subtracted X squared and Y squared from this equation, equation number 2. And in conclusion, we found out that R squared minus X squared minus Y squared equals to 18 times R minus Y according to equation number 2. Then, here, from point C, we do perpendicular to BE. So this again equals to 90 degrees, this again equals to 90 degrees, and we define the touching point of the perpendicular from point C to BE is point Q. So here in quadrilateral QCEF, this quadrilateral QCEF, we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle QCF. In total, the sum of those 4 angles, the total sum of those 4 angles must be equal to 360 degrees. So 270 degrees plus angle QCF must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that angle QCF equals to 90 degrees. Therefore, quadrilateral QCEF that has 4 right angles, it is a rectangle, and the opposite sides of a rectangle are equal to each other, that is to say CF equals to QE. CF equals to QE, but CF equals to 1 unit, it is the radius of the smallest circle. So from this equation, 1 equals to CF equals to QE, we will conclude that QE also equals to 1 unit, if QE equals to 1 unit. Okay, and then we joined points B and C together by a straight line. And what is the value of BC? B is the center of this circle, that its radius is equal to 9 units. C is the center of the smallest circle, that its radius equal to 1 unit. Those two circles have an external notch between them. That is to say, they are touching each other externally. And whenever you have two circles that are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, the radius of this circle is 9 units. The radius of the smallest circle is 1 unit. So the distance between their centers will be equal to 9 minus 1, that is 10. So we found out that BC equals to 10 units. So here we can write down that BC equals to 10 units. What is the value of BQ? Here BQ, you can see it easily from the drawing that BQ equals to BE minus QE. Again, BQ equals to BE minus QE. So BE is the radius of this circle that equals to 9 units. We have already found out that QE equals to 1 unit. BE equals to 9 units and QE equals to 1 unit. In conclusion, we found out that BQ equals to 9 minus 1, that is 8 units. So the only missing variable here in this right triangle is QC. So we implemented the Pythagoras theorem on this right triangle, triangle BQC. So here we will get that BC square equals to BQ square plus QC square. BC equals to 10. So BC square is 10 square, 10 square is 100. 100 equals to BQ square. BQ is 8. BQ square is 8 square. 8 square is 64. So we got that 100 equals to 64 plus QC square. We subtracted 64 from this equation, and we got that QC square equals to 100 minus 64 is 36. So QC square equals to 36. We took a root out of this equation, and we got that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units. And we have already found out that QCEF, quadrilateral QCEF, is a rectangle. And the opposite sides of a rectangle are equal to each other. That is to say, QC equals to EF. QC equals to EF, but we just right now found out that QC equals to 6 units, so EF will be also equals to 6 units from this equation. EF will be also equal to 6 units. Then from point C we do perpendicular to OM. And actually quadrilateral UCMF is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, CF equals to UM, but CF equals to 1 unit. From this equation we will get that UM also equals to 1 unit. So UM equals to 1 unit. And here we have already found out that, and here we know that UCMF is a rectangle, and the opposite sides of a rectangle are equal to each other. Because of the fact that UM equals to CF, then UM will be equal also to 1 unit, and we also know that UC equals to MF. UC equals to MF, according to the rule that the opposite sides of a rectangle are equal to each other. But we have already found out that MF equals to x plus 6. So from this equation we will conclude that UC also equals to x plus 6. So we know that UC equals to x plus 6. And what is the value of OU? OU equals to OM minus UM. OU equals to OM minus UM. But OM equals to Y according to our definition. UM equals to 1. So in conclusion, we found out that OU equals to Y minus 1. And what is the value of OU? O is the center of the biggest circle. That is radius is equal to capital R. And here C is the center of the smallest circle, that is radius equals to 1 unit. Those two circles have an internal length between them at this point. They touch each other internally at this point. And whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest circle, that is capital R, minus the radius of the smallest circle, that is 1. That is to say, it will be equal to R minus 1. So we found out that OC equals to R minus 1. So here we can implement the Pythagoras theorem on the right triangle, triangle OUC. Okay? And we implemented the Pythagoras theorem on the right triangle, triangle OUC. According to the Pythagoras theorem, OC square equals to OU square plus UC square. And here we have OC square equals to UC square plus OU square. OC equals to R minus 1 square. UC equals to X plus 6 square. And OU square equals to Y minus 1 square. So this is equation number 3. We found out that according to equation number 3, R square minus X square minus Y square equals to 2 times R minus Y plus 36 plus 12X. And this is equation number 2, this is equation number 1. We created equation number 4 that says that Rx minus X square minus Y square according to equation number 1 must be equal to R square minus X square minus Y square according to equation number 2. And from equation number 4, we found out that R minus Y equals to 72 minus 12X over 5. Then we created equation number 5 that states that R square minus X square minus Y square according to equation number 2 must be equal to R square minus X square minus Y square according to equation number 3. This is equation number 5, and from equation number 5 we got that R minus Y equals to 36 plus 12X, or R minus Y equals to 9 plus 3X over 4. Then we created equation number 6 that states that R minus Y according to equation number 4 must be equal to R minus Y according to equation number 5. And from equation number 6 we found out that X equals to 27 over 7. We put the value of X inside equation number 5, and we found out that R minus Y according to equation number 5 equals to 36 over 7. We already found out that according to equation number 6, X equals to 27 over 7. Then we have equation number 2 that states that R square minus X square minus Y square equals to 4 times R minus Y. Here R square minus Y square equals to R plus Y times R minus Y. And then we substituted X by 27 over 7 and R minus Y by 36 over 7. And we found out that R plus Y equals to 585 over 28. This is according to equation number 2, but according to equation number 5, we have already found out that R minus Y equals to 144 over 28. We added equation number 2 to equation number 5, and we found out that 2R equals to 500 85 plus 144 over 28. 2r equals to 729 over 28. We divided this equation by 2 and we found out that the radius of the biggest circle equals to either 729 over 6 over 56 units, or in terms of numbers it equals to 13.018 units. Repeat again that the radius of the biggest circle equals to either 729 over 729 over 56 units, or in terms of numbers it equals to 13.018 units. Okay, that is the answer to the question. Okay, thank you very much.